Hi, my name is Mike Scott, Industrial Product Manager at the Modal Shop for the portable vibration calibrators. And in this video I'm going to show you how to create a dynamic calibration of both frequency response and amplitude response for your proximity probes. I have here our Model 9110 portable vibration calibrator that allows you to create ISO 17025 accredited calibration certificates. I have our proximity probe mounting hardware, and if you'd like to see a video on how the probe is mounted, you can click on the video link below or visit the Modal Shop's YouTube page or the Modal Shop Video Vault on modalshop.com. I also have a digital voltmeter that will allow me to measure the gap voltage, and of course my Bentley Nevada proximity probe and proximeter. The first step in performing a dynamic proximity probe calibration is to set the gap voltage and set the gap distance to 50 mils. So what I'm looking for on my voltmeter is -9 volts DC. So I'm going to turn my micrometer on my proximity probe adapter kit until I see -9 volts DC on the voltmeter. And this doesn't have to be the most precise measurement unless you're planning to shake the target at 40 mils peak or 80 mils peak to peak and use the proximity probe at its full range. But for good practice, we want to put it at 50 mils, which is the exact center of the proximity probe's dynamic range. So now we're ready to perform our proximity probe amplitude response calibration. The first thing I want to do is make sure my calibrator is in voltage mode. I hold down the amplitude button and I see sensor type voltage, so I'm good to go there. I can now disconnect the proximity probe from the voltmeter and connect it to the calibrator here, test sensor input. Like so. And now I want to change my amplitude scale to mils peak to peak by pressing the amplitude button. You'll see I scroll through G's and inches per second, and now I'm at mils peak to peak. And I'm going to start off at 5 mils peak to peak. The output of my accelerometer should be proximity probe should be 200 millivolts per mil. You can see I'm at 208 millivolts per mil, reading slightly high. So now let's create a calibration certificate for amplitude response for this proximity probe. I'm going to start all the way down at 1 mil peak to peak and save the point by pressing the file button. I'm doing this at 60 hertz, which is 3600 CPM. You can see I can toggle between hertz and cycles per minute by pressing the frequency button. Now I'm going to rotate up to 3 mils peak to peak and save another point. Sensitivity has remained at 207. Let's go to 5 mils peak to peak. Now if you weren't creating a calibration certificate and you had your proximity probe hooked up to the online system, at this point you'd be checking to see if your alert settings have tripped. Maybe the set point is set at 5 mils peak to peak or even lower. So in the field for a plant floor or an in situ calibration at the machine site, you can actually check your alert and alarm levels. And notice as I change my amplitude in mils peak to peak, I don't have to remove the sensor and replace a micrometer. The shaker's controlling it and changing it for me. The shaker's making sure that I remain at 60 hertz so I don't have to change the frequency constantly. It's a closed loop control, which makes it very easy to quickly move to my different amplitude points. That's good enough, 20 mils peak to peak. This actually has the capability of going to 100 mils peak to peak. That's a little bit high for a typical application, of course, quite high. So for this example, I'm just going to go to 20 mils peak to peak. Let's save our calibration record. Turn the file knob to end record. Press the button. This screen gives you a chance to enter the model and serial number. I'm going to skip that for now. We can do that on the calibration certificate. And this screen gives you a chance to enter notes. I'm going to skip that as well. Press save, and we're done. Another thing I can do with the calibrator is do a frequency response check. You can see I can rotate the frequency down to 30 hertz or 180 cycles, or 1800 cycles per minute. Check the output at that point, 207, and I can rotate up to 150 hertz at any point in between. And you'll notice on our proximity probe that the output starts to increase just a little bit when you get up to these high speeds. 150 hertz, 212 millivolts per mil. This is 9,000 cycles per minute, so I'm a little bit high at that point. And at this point, we're ready to insert the USB. Like so. Rotate the file button first, press Tools, and press USB menu. Copy all records. And now our calibration records have been stored onto the USB drive. I can press Eject USB. USB drive is safe to remove. Remove my drive, and now it's time to go to the computer. Now it's time to create our ISO 17025 compliant calibration certificates. I've inserted the USB into my computer, and I'm going to open the folder. And I will open the 9110D Report Generation Workbook. This runs in Microsoft Excel. No need to install any new software. Make sure you enable macros by clicking there. And now we're ready to import our data. So let's take a look at our frequency response data. Import the data from the file. Choose our removable disk where we save the file from our calibrator. It's sorted by date. Here's my frequency response information. You see my amplitude in mils peak to peak stays steady, and my frequency in hertz moves from 30 to 150, and my sensitivity starts to increase at 150 hertz, and you see my deviation. But let's view the certificate. And this is an ISO 17025 compliant certificate. I can enter the model number and serial number here, and any notes that I would like to enter as well on the calibration certificate. Let's also create our amplitude response certificate. Click Linear Data, Import Data from File. I will choose my linearity plot here, which was the third record that I saved. There you see our output, our sensitivity millivolts per mil, and our output in millivolts increasing as our input increased. And let's view the certificate. And there's a nice look at our linearity plot and our calculated linearity. And again, I can enter the model number and serial number as well. And you see the sensor was very linear in this calibration. At this point, you can bring it, you can print it, store it in your files. We've created our calibration certificate. So now you know how to create ISO 17025 compliant calibration certificates for your proximity probes. Thanks so much for watching. For more information, including a video on how to mount the proximity probe to the calibrator, please visit modalshop.com.